So far, all the different systems that we've looked at have had an answer. The answer is x is 3, y is 4, something along those lines. So that when you graph them, the lines cross somewhere. But there are some special cases that we're going to look at. So one special case would be if we have parallel lines. Since parallel lines never cross, and the solution is where the lines cross, then that means that there could be no solution if the lines are parallel. And then another special type is concurrent lines, which really just means they're the same line. If they're the same line, then they're going to be graphed on top of each other. So then every single point along the lines would touch. So this is going to be all solutions. And then just to remind us, to be parallel, they have the same slope, but different y-intercepts. And if they're the same line, it would have same slope and same y-intercept. So when we start solving these, we're going to solve them the same way that we've been solving other systems, but we might get a no solution or we might get an all solutions. So let's look at this first one. We have a couple different methods. I'm not going to choose to graph these. I'm either going to use substitution or elimination. And I'm going to choose to use elimination. I notice that if I multiply this top equation by positive 2, that would make a 2x on top with negative 2x on the bottom, so that x's would cancel. So I'm going to distribute that 2. 2 times x is 2x. 2 times negative 3y is negative 6y. 2 times 9 is 18. And now when I add these equations together, negative 2x plus 2x makes 0, so that goes away. But also positive 6, negative 6 also goes away. So on this left-hand side, there's nothing left, so we put a 0. And then on the right-hand side, negative 18 plus 18, that's also 0, so there's nothing left, we put a 0. And then we look at, is this a true statement? Does 0 actually equal 0? And because it does, this tells me that this is going to be those all solutions. These would be the exact same line. If I were to rewrite both of these in slope-intercept form, we'd see that they have the same slope and same y-intercept. Number 2, this one's already set up perfect for elimination or combination because I see negative 4y and positive 4y. Those are already going to be eliminated or cancel out. So 4x plus 2x is 6x is equal to 8 plus 4 is 12. And then if we're just trying to find out how many solutions, I could stop here because I have a variable f, which means I'm going to have a solution. But if we want to know what that solution actually is, we could keep solving. So we divide by 6, x equals 2. And then remember, we take that variable we found and we plug it into one of the equations. So if I know x is 2, I can go up to like this top one and replace x with 2. So that becomes 4 times 2 minus 4y equals 8. It's going to be 8 minus 4y equals 8, minus 8 from both sides. Negative 4y is equal to negative 8 minus, or 8 minus 8 is actually 0, which is okay. It's just the answer. Can be 0 sometimes. We divide by negative 4. 0 divided by negative 4 is 0. So now we have the second part of that answer. So our answer to this system is going to be 2, 0. So they would cross, and they would cross at that point 2, 0. So that one does have a single solution. I could have graphed. I put graphs on here if you wanted to. I think graphing is not always most accurate, so I tend to use that method as a last resort. I'm going to do the same thing here. I'm going to choose not to graph these. You could graph these if you wanted to. Let's use a combination on these. If I multiply this top one by negative 1, that's going to give me a negative 1x, negative 2y, and negative 8. And then I can add those together. Negative 1x and positive x make 0, but so do the 2y And the negative 2y also makes 0, so there's 0 left on the left-hand side. On the right-hand side, we have 6 and negative 8 makes negative 2. So on this one, 0 does not actually equal negative 2. That is not a true statement. So that tells me I'm going to have no solution. So if I were to graph these, I would have parallel lines. Lines that never cross. They don't ever cross, there can't be a solution. And then for number 4, I'm going to choose elimination again. I'm going to choose to multiply the top equation by negative 3 to make those x's cancel. So negative 3 times x is negative 3x. Negative 3 times y is negative 3y. And negative 3 times 0 is 0. And then the x's cancel. That was what I wanted. I have a negative 2y and negative 3y makes negative 5y. And then 10 plus 0 is 10. Again, if I was just trying to find out how many solutions, I could stop. If I have a variable left, that means I have a solution. If I want to know what that solution is, I need to keep solving. So I'm going to divide by negative 5. Y equals negative 2. So we got our first value. We know that the y value has to be negative 2. So I'm going to come up to the first equation just because it looks easier. It was x plus y equals 0, but now I'm going to replace the y value with negative 2. So then x plus negative 2 equals 0. Then we have to add 2 to both sides to make that 2 cancel. X equals positive 2. So then we have the solution to this would be the point 2, negative 2. Again, you could choose to graph, you could choose to use substitution, whatever method you're using. If the lines are parallel, or like this where we get an untrue statement and there's no solution. If the lines happen to be the exact same, or we get a solution like this where we do have a true statement, then that's all solutions. Every other case is going to end up with some kind of answer. And if you are going to end up with a variable left, you're going to have a single solution.